Hello everyone, I am Kiran and today we are studying about the order of subshells. To write the electronic configuration there are two ways. One way is by shells and the other way is the subshells, right? Shells is quite easy. We will use the different energy levels and we will place them electrons in like K, L, M and shells like 2, 8 and so on, right? While the subshell is quite complicated because there are too many subshells, right? And we need to place them on their increasing order of energy. So that's what we are going to today. We will going to know how these subshells work, how their energy works, and at the end of the video I promise I will make this electronic configuration a cake easy for you. And if I will ask you at the end of this class, this is zinc and it have atomic number as 30, so write its electronic configuration and you all gonna write like 1s2, 2s2, 2p6, 3s2, 3p6, 4s2 and 3d10. If you are finding that right now it's quite complicated, just we need to follow these 3 steps, and after these 3 steps we going to know how to write the electronic configuration. Okay, so let's start with, so the first step we need to follow to know the quantum numbers. Okay, quantum numbers. So we don't need to go very depth about the quantum number, and there are 4 quantum number. We will use just 2. I will tell you everything about that, and we don't, as I'm saying, we don't need to know quantum number. We just know the like a basic. So we have 2 quantum number here which we are going to use. So the first one we are using, we call it as the principal quantum number, and we represent this principal quantum number by the small n. Second, we have the orbital angular quantum number. Orbital angular quantum number, and we represent it by the small l. Why we are using these 2 quantum number? So the principal we use to know the shells, right? And the orbital we are using to know the subshells, because we should know both shells and subshells to write the electronic configuration on subshell level. The second step which we will follow, after knowing the shells and subshell, we will arrange them in order of their energy. So we will calculate their energy, and it's not mathematical equation, it's very easy kind of thing. So subshells we will do, and the third step is the last one. We will order them and we will arrange them on their increasing order. Okay, so we just need to follow these 3 steps. First we will start with to know the quantum numbers. As I told you, we don't need to know too much. We will just start with the first quantum number, that is principal. So principal we represent by the small n, and it shows us the energy level, like how far electron is from the nucleus. Okay, so let's suppose I have this atom, and the first shell, second shell, and we made shell like that. So the first shell will have n value as 1, the second shell will have n value as 2, and in the same way n3, n4, 5, 6 and so on. And for the first shell we call it as a K shell, then we call it as L, then we call it as M, and then we call it as N, and it will work like that. Okay, we just need to know what is the principal quantum number for the given shell, and we will know which shell they are talking about. So principal quantum number help us to understand how far energy level is from the nucleus. And then we have the second one. Second one is a bit more important for us, okay, compared to the first one. So second one is, we call them as the orbital angular quantum number. As I told you, it is L, right? And L value is totally depend on the n value, means the principal quantum number. The value of L can be range from 0 to maximum it can be n-1, and based on that we have 4 value of L. Just for after 4 we haven't found still. So we have this L value as 0, 1, 2 and 3. If it is 0, we call it as the S subshell, that represent as the sharp. For 1 it's P, and we call it as principal. For 2 it's D, and that represent actually the diffuse word. While the 3 it is F, and it represent the fundamental. So we have altogether 4 subshells, and you can see these names, and these names actually we use from the quantum numbers. Okay, so based on these 4 subshells, we have 4 blocks in the periodic table. We have these 4 blocks. The first, these 2 shells we call this S block. Then we have here to here, we call it as P block. This one from this to this side, we call it as D block, and this one is we call it as F block. Now, how do we know that every block, how many shell, how many group present in every block? So in case of S, you know there is only one orbital. In case of P, we have total 6 orbital. In D, we have total number of 5, and in case of F, we have 7. Every orbital can have two types of electron, one with the this upside spin, and second is downside. Upside represent the clockwise and the downside represent the anti-clockwise direction actually. But here just remember that every orbital can have 2 electrons. In this way, S can have 2 electrons, P can have 6, D can have 10, and F can have 14 electrons, right? Now, based on that, we can have 2 types of electronic configuration for the S. One is S1 and one is S2. And you can see that's why we have 2 types of shell. So the first shell will be S1 type and the second will be S2. In the same way, P can have 6 electrons. That's why we can have 6 type of electronic configuration in P block. How? P1, P2, P3, P4, P5 and P6. That same way work for the D and for the F also. Okay. So based on that, we can have total 4 blocks in the complete periodic table. Okay, so after that, see, if we know all these things, now what we need to do, we need to make the total subshells for the every shells. So principal quantum number can be 1, 2, 3 and 4, and based on that we can have shells like the K shell, the L, M and N. I am using just 4, but in reality we have more than 4. How? Because we have element till 120 and we need to fill electron in that much. So just remember that shells are only 4 type, S, P, D, F, but we can have shells different type. So in case of first shell, we have only one subshell, that is S, while in case of L we have S and P. In case of M we have S, P and D, while in case of N we have S, P, D and F. And the problem is that we have S in all 4 shells, P in 3, in D in just 2 and F in 1. We can see right now, right? But as I told you, we can have more than these 4 shells, right? So to make it differentiate, to make them like separate, we will use the principal quantum number before that. Like it will be 1s, it will be 2s and 2p, it will be 3s, 3p, 3d, 4s, 4p, 4d and 4f. Okay, and based on that we have these different shells, subshells now, right? Now the second step, let's move to the second step, and that is the energy. How we calculate the energy? So that is the energy of subshells. So to calculate the energy of subshells, we should know these 2 things. One, we call it as N, you know N, right? That is principal quantum number. And the second we have L, and I think you know L also, that is the orbital angular quantum number, right? And let's start this one, and it's quite interesting. See, first shell only have 1s, second shell have 2s and 2p, third have 3s, 3p, 3d, 4 have 4s, 4p, 4d and 4f. Next have 5s, 5p, 5d. Sorry, it's 4. No, it's not 4. It's 5. It's 5d, 5f. Then we have 6s, 6p, 6d and 6f. Let's make the 7 also, so that we can range. We can increase our range to the last elements, right? Then we have last one is 7. We will start with the 7. So it will be 7s, 7p, 7d and 7f. Now what we need to do, we need to calculate their energy. As I told you, we have a formula, that is N plus L. So how you can remember that? So you know the number in front of these subshells, that like here in case of 1s, N is the N value, right? So if we want to calculate, just remember that L can be 0, 1, 2, 3. If it is 0, it's S. It's P, D and F, right? So just use this number. So I am calculating only for few, and then I will write down. You will calculate for everything so that you can remember it, right? So for 1s, it will be 1 plus 0. It's just 1. For 2s, it will be 2. Here this is 3, 3, 4, 5. 4, 5, 6, 7. 5, 6, 7, 8. 6, 7, 8, 9, 7, 8, 9 and 10. It's very easy, and if you know these numbers, you know it's very quite easy to put them on the increasing order, isn't it? But there is one more thing. What? There are some numbers which is actually same. Why? You can see this one, right? 2p and 3s both have the same number as 3. In case of 3p and 4s, they have the same number as 4. And 5 have 3d, 4p and 5s. What do you think? If we have same number, we will use the rule of the principal quantum number. Whichever have the lowest principal quantum number will have the lowest energy. Okay, just remember, the one which will have the lowest principal quantum number, which will be at the lowest energy. Okay, so it means when we have this 2p and 3s, we will place 2p first and then 3s. In the same way, if we have 3p and 4s, because 3 have less principal quantum number, so 3p will be first and then 4s. In this way, if we arrange them, so it will look like that. So the first will be 1s, then it will be 2s, then it will be 2p, 3s, 3p. I hope you also trying to write electronic configuration by your own. Then 3p. In case of, then we have 4s, then we have in 5 we will first write 3d, then we will write down as 4p, then 5s. In case of 6, we will first write down as 4d, right? Then we will write down 5p, then we will write down as the 6s, right? And in case of 7, first we will write down as 4f, then we will write down as 5d, and then we will write down as 6p and 7s. See, in that case, you don't need to remember, just remember that maximum shell we can have, subshell we can have just f, right? S, P, D, F. And first one will have only one subshell, then 2, 3 and 4, and then later it will remain as 4. And we will just increase the principal quantum number, and based on that we are getting this order. So we can write down like that, right? So let's move to the next page. So this is the last one, and that is the order of the subshells, right? Because we know first is 1s, then it is 2s, 2p, 3s, 3p, then 4s, 3d, 4p, and then we have first as, let me just check, after 4p we have 5s and 4d, 5s and 4d. That much you need to remember till now. Let's try to write down the electronic configuration based on that. What do you think? So if we have the electronic configuration for this one, zinc now. I told you that you can write down, right? You know that S can have 2 electrons, P can have 6 electrons, D maximum can have 10 electrons. Write down. And I hope you can write down, right? So want to write electronic configuration with me? So start. So it's 1s, it will be have 2 electrons, then 2s will also have 2 electrons, P will have maximum 6 electrons, then 3s we will have 2 electrons, 3p 6, we have 4s as 2, and then we have 3d as 10, and it's 30. And I will say that try this electronic configuration with as much as you possible. That's how you will start it, okay? So I hope this is clear for you.